So a little bit about myself. Software engineer for a company called Century One, logo, based out of essentially Charlotte, North Carolina. And we write software that helps analyze and performance monitor a whole bunch of stuff. So if you've ever dealt with SQL Server, which I bet we have at least one .NET dev in here. Yeah, there we go. Or you do VMs or Azure, any of that stuff, we sell software to help you with that. We're also hiring. So if you're interested in a job, please let me or that guy in the back who can actually make that decision know, and we'd love to chat with you. Microsoft MVP in developer technologies, which means I do a lot of conference speaking and make a fool of myself every now and then. And I run a functional meetup and user group, and conference in Knoxville. So there's it about that. So with that being said, enough about me in that sense. Let's talk about me in the past. So I kind of want to start with the journey. Why did I even go down this road of functional? So my background was OO developer, C++ in undergrad, and then in the real world where I actually had to find a job, it was C# and .NET. So I kind of want to talk about how did I even start looking at functional, how did it come to be, and what some of the motivations were. And this is really paramount because this kind of dictates everything else and this kind of transformation that's happened to me in the last 3 years. So first, the inspiration. How many of y'all have ever heard of the phrase solid design principles? That's kind of a phrase? Okay, cool. So for those who may not be aware, solid is just a mnemonic for a series of design principles, and there's 2 letters in particular I want to talk about. S, or single responsibility, and then I, the interface segregation. So I'm going to do the cliche thing in a presentation, put a quote. So from Wikipedia, the single responsibility principle states that every module or class should have responsibility over a single part of the functionality provided by the software, and that the responsibility should be entirely encapsulated by the class. That's a whole bunch of word soup. Here, let me condense that down for you a little bit. Every module or class should have responsibility over a single part of the functionality. That's an interesting thing, right? Encapsulated in a single class or module. What happens if we take that to the extreme? What happens if we take that principle? What's a responsibility? How do we define that? Everything I've read is intentionally vague. It's kind of like, whatever you think. Robert Martin, who was the first one to kind of put single responsibility in a book, recently released Clean Architecture last August. And even then, he redefined what responsibility meant, as in, like, it depends on your business. Shit, that's not helpful. I can't do that. So what I found myself doing, though, is if I follow single responsibility to the utmost extreme, I started writing a lot of code that looked like this. I would have an interface, because interface is the right thing to do. I tells me that, and so is the dependency inversion principle. But so I usually would define an interface with a single method, and then I would have a class with a single method. Maybe there was a private helper shoved in there. But this is essentially what I ended up writing all my code as. This sucks. This is awful, because this definitely isn't OO. I've now completely went back crazy off that. But also, I'm now having to find an interface for every single one of my classes. Each one of those classes have a single method. This seems awful. And yeah, there are tools. ReSharper can auto-generate interfaces for me. Visual Studio 2017 can do that for me too as well now. But there's got to be something better. I've missed the boat. So I did the smartest thing ever. I asked Twitter. So I actually posed out to the community, hey, I catch myself refactoring and doing this stuff all the time, which I thought was a good thing. In my head, it made things a lot simpler. But is there something else I'm missing? There's got to be more than this. And in one of the brief bouts of awesome, some helpful person responded. No trolling at all. So excuse the old Twitter handle there, but the guy said, potentially some other parts of solid. I think you know what the rest of the way looks like. And he gives me this link to a post we'll take a look at called Solid. The Next Step is Functional by Mark Seaman. If you're not sure who that is, if you've ever heard of the book Dependency Injection in .NET, that huge tome, anybody heard of that book? He's the author. Kind of knows what he's doing. Very, very sharp guy. He's written a couple of open source libraries. I think AutoFac is probably the most popular one. But anywho, so tons of stuff. And so I read this and I was like, oh man, I thought I came up with something new, and of course someone beat me to it. That's how it is. So I kind of wanted to dissolve a little bit what some of the things that Mark talks about in his blog post. The first thing he mentions that if you do take this single responsibility and interface segregation to the extreme, you end up with a lot of these classes, a lot of these fine-grained classes. You get a crap ton of them. And so he challenges the paradigm and go, okay, objects have always been thought of as data with behavior attached to it. In fact, I guarantee if you look at the traditional definition, that's what you ended up with. What if we flip that idea around? What if we switch it to behavior that has data? Like we have behavior that takes data in. Okay, that's functional programming. That's kind of where he comes from. So that was kind of cool. And I highly encourage you to read that post because it fundamentally changed the way I looked at problem solving. I've read very few things in my life that have done that, but that blog post was one. Yes, so I should have mentioned this at the beginning. The slides are online, all the resources are online. If you go to my blog, blog.softwarementor.com/presentations, everything's already there and live. So you shouldn't have to frantically take notes. Sorry for the ones who've been doing it, or any of that stuff, it's already there. So excellent question, thank you. I should have mentioned that at the beginning. So I read this blog post and I was super inspired, like, all right, I gotta learn functional, I gotta do this. I got to scratch this itch because there's a better way. So where do you start? There are a lot of options out there. If you were in the room a little earlier, we were talking about ReasonML, which didn't exist in 2014. There was Haskell, which to me at the time was this esoteric language that no one used. Though that's totally not true, but 2014 Cameron was a lot more stupid than 2018 Cameron. And then there's Scala and all these languages. I didn't know what to choose. So after doing some digging, I actually ended up choosing F#. And there were some compelling reasons why. First of all, it works with the .NET runtime, and it works with Visual Studio, which means all my tooling is there. Oh snap, I didn't have to learn a new editor. I didn't have to learn a whole new tool chain. All my tips and tricks and refactoring for the most part still there. Yes, like a security blanket, I could clutch it. Also, there are a lot of great resources already online for it. F# for Fun and Profit is a fantastic website to go from 0 to 60 in F#. Also, there were devs in Knoxville that were doing F# for their day job. So it's like, okay, cool, I can ask this hypothetical expert across the pond, or I can ask you, Reed Evans. You're right here, I can borrow you for a bit. So that's kind of the reason why I chose it. It was kind of familiar enough, and it worked with .NET, which I thought would make it really useful. So we've talked a little bit now about what made me look at functional, and even a little bit why I chose F#. I want to talk a little bit more about the path. I've decided to do functional, let's do this. So I'm going to be honest, it took me 1.5 years to really kind of understand functional. Now there were a lot of pauses in there. Like I would be heads down for a little bit and then come back up, and heads down again for a little bit and come back up. And it was frustrating. There were plenty of times I'm like, this is the stupidest thing in the world, and the table flip. But I got better. And so I explained this to you to kind of tie into the keynote a little bit, but like, hey, sometimes we have to go outside our comfort zone, but also let you know that you're going to probably struggle, and that's okay. That's normal. It's a new thing. You're having to rewire the way you think about problems. So my first attempt. Now see, originally when I was speaking before lunch, this would have been a lot more funny, but that's okay. Yeah, and in hindsight, this is exactly what my first step looked like. Maybe biting off a little more than I could chew. So my idea was, you know what, I'm going to port a pre-existing C# application I have to F#. Simplest thing in the world, right? Because the idea is I already know how to solve the problem. Problem's been solved. I'm just going to learn about the F# syntax. So this application I wrote was called Task Snapper. And all it is, it's a Windows service that runs in the background that takes a screenshot every 15 minutes of your desktop. The inspiration behind it is because I'd get asked at the end of the day, hey Cameron, what'd you work on today? And I'd have no clue. Task Snapper solved that problem for me. I could always go through my images and go, yep, so Visual Studio, I was doing that. Yep, there was those Stack Overflow posts, so on and so forth. So the reason why I chose this app is because it was already solved, and like I mentioned before, I get to focus on how would I do this in a new language because the syntax bazaar is all get out, right? So let me show you what one of the components of this class looked like, and I apologize for those who are faint of heart. Big block of scary code. Don't focus so much on reading this right now. I'm just going to talk a little bit about what I did. So this application could be started via command line, the command line had some arguments. So you had to validate that those arguments weren't garbage, right? A path and an interval. So I did the really smart thing. First, I defined a type called a command line validator, and it took in 2 parameters as part of its constructor, which was kind of cool. And then I defined some functions attached to it, some method level things. Get parameters, which would actually take a list of string and do some stuff with it, and find argument and parse argument. So now I've got some methods attached to this object. And when something was bad, I would throw this exception using this cool new keyword I learned called raise. All right, and so I did it. I did this port, and it was awful. This was so bad because I did not write F sharp. I wrote F sharp. I did not write functional code. What I did was I fell into the trap of writing object-oriented code in F sharp because F sharp supports that. On one hand, I wrote F sharp. That's kind of cool. I proved that it works, it compiles, it does stuff. Yay. On the other hand, this is not even close to idiomatic F sharp. This would be the equivalent of me being a C++ developer, and I decided to write .NET, and so you see me doing pointer and memory management on my own. And I didn't really see the point because I had to learn this weird syntax to do classes, and then C# does it better, so I was like, what the hell is the point? So I table flipped, walked away from it for a while, and said, this is the stupidest thing in the world. And then I did another smart thing, and I asked other people to read my code and say, hey, what do you think? And they told me, Cameron, you wrote a class and attached methods to it. It's not functional. Could you not do that? Okay. So after a little bit of time and thinking about it, I was like, all right, I'm going to read some more. So I found out that a really good tutorial application to write when learning functional is card games. It kind of is a cuddlier introduction to a lot of the cool tips and tricks. So I was like, all right, cool. I'm going to do that too. Do we have any board gamers in the room? All right, cool. So some of you are familiar with this game, Love Letter. But for those who are not, I'll give you a little bit of description. So it's a card game that has 8 different kinds of cards, each with their own rules. And really the idea behind it is that everyone's dealt a card, and every turn you draw a card, play a card. And the result is to either be the last person standing or to have the highest value card in your hand. That's kind of the high level gist. So the rules for me trying to implement this behemoth was no classes, no exceptions. That was it. Everything else was fair game, but I removed those from how to solve the problem. Because I realized that's what got me in trouble last time. All right, let me show you some of the cool stuff I learned. So here's some F sharp code. You don't have to be an F sharp expert because I'm going to explain what all this stuff does. So first and foremost, I learned about how to model data types that only allow certain things. So let's take a look at a card. So this card type can only have one of 8 possible values: guard, priest, baron. These were the name of the cards, for those who may not aware. But what's really cool is when I modeled card this way, it can only be one of those 8 values. I can't create a card called kumquat. It doesn't exist. It won't work. It's a compilation error. And so the game condition was another type that I was able to create. And so the game was over is when either the deck ran out of cards or there was only one player standing. And then there's continue. So that means that when I was modeling the game can only be in one of those 3 states. It couldn't be in anything else. Either we had to keep playing, or we ran out of cards, or there's only one player left. Awesome. Okay. So this was kind of cool that I could model data in this way. And for the .NET developers, you're probably looking at this and thinking like, okay, it's enum's a big deal. Not quite. Those who have hacked enums before know that they're just integers under the hood. You can typecast like 100 into an enum and it would work. This will not work. That trick would not work here. This is an actual type, which is kind of cool. Here's some other things I learned. I learned about aliasing types. So I created this type called a deck, and I essentially say like, well, a deck is really just a list of cards. All right, cool. That doesn't sound super impressive, except now I can write signatures that say I take in a deck. My code now reads closer to the problem at hand instead of seeing list cards sprinkled through my code base like salt, right? Here's something else I learned, which is pretty cool. How do you actually model data? So I was able to create a player, and I said, well, a player in my game It has to have a player number. The reason why is because player 1 is definitely different than player 2. Those are two different things. Every player has at least one card, and in fact, only one card. And there were a couple of states, and I'm not happy of how I modeled it back then, but there was a card that could protect you from bad things. So if you played it, you were protected. And if you were taken out because another card like removed you from the game, is out. And then I could define another type called game, and I said game, well, game's really simple. It's got a list of players, it's got a deck, it's got a card that's set aside at the very beginning, that's just based on the rules of the game, and then it has a game condition. Holy crap, Batman, this is succinct. This somewhat reads close to what I'm trying to model. Awesome. So, the other thing I kind of want to point out to this a little bit, there's no classes here. There's no exceptions. I was able to do a lot of, this is where I learned how to model data in such a way that I can't have crap state created, right? We've all heard of garbage in, garbage out. Well, the thing I found I really appreciate with functional coding is that I can actually design my type so that bad things literally can't happen because the compiler won't allow it. The code literally can't compile because it's there. That's awesome. So let's reflect a little bit about this. So love letter was a lot of fun because I learned all this stuff, but the rules were super complicated. I bit off way too much more than I could chew because there are all these weird interactions that I'm like, I'm not sure how those rules would work in a real game, let alone a simulated game. And then so I have to go to Board Game Geek and try to find out, and someone's like, well, I've house ruled it this way, but the errata says this, and the game company says this third other thing. I'm like, oh hell, I've got crap requirements. Imagine that. Even in my side project, I've got crap requirements. Oh. So, not completely discouraged. I still did a table flip and was like, damn it, not again. So I set it aside, but I keep thinking about this. I keep thinking about these things. And after a couple of weeks, I come back to the drawing table. I was like, all right, I got this time. I'm gonna stick with the card game, all right. Let's do something a little more traditional where there's not some flaky rule out there that's gonna bite me in the rear at the end. So my third attempt, I was gonna model the age-old classic Blackjack. Okay, cool. So here's some cool things about it. It's still a card game, which means a lot of the stuff I learned in the love letter implementation still apply, okay? The business rules have totally been defined. There are no ambiguities. You know why? Because it's in the casino. Do you think casino will allow you to gamble with money on ambiguity? No. So we're good. And also I was really comfortable with the rules. The other thing about Blackjack is I can add as much complexity as I want. If I want to support like splitting and like doubling down all that, I could, but I didn't necessarily have to. Whereas with Love Letter, it was kind of an all or nothing. Either I had to do the whole thing or none of it. So this let me actually break it down in smaller components. Let me show you some of the cool stuff I was able to do in this game that borrowed from Love Letter and such. So this is how I modeled a card. So I said, okay, well, there's this thing called a rank, and a rank has one of these possible values, ace through king. And people who are familiar with the traditional deck of playing cards are like, yeah, no, I got this. And the suit is one of those four values. And I said a card is a combination of a rank and suit. So just in these few lines of code, I've prevented the developer to create, so they cannot create anything that's not a combination of those two things. I can't say an ace of platypus because I won't compile because platypus is not a suit. And I can't say a kumquat of clubs because kumquat is not a rank. I can't coerce the types, I can't do anything. This is all I can play with. Awesome. I'm modeling state in a really succinct way now. Okay. Here's something else I learned in this implementation that was pretty cool. Real life, you have a hand in blackjack. How would you score it? And that's a question to the audience. How would you do that? In real life, no code, just you've got a couple cards in your hand. How would you score it? Addition. All right, I heard addition. Are you just going to, so what are you adding?
Number of cards and 10 as a base card or 1 or 11.
Okay, so it sounds like, can I paraphrase a little bit? So it sounds like you got to figure out how many points a card's worth and then add them. Is that fair? Fair statement? I promise he's not a plant. He's a real life attendee. I did not coach him. Okay, cool. So let me show you how I did that. So this is really scary, but not really. So I defined this new type called points. And the reason why I had to do this is because if you've ever played Blackjack, there's a card that's a little bit interesting when it comes to points, and that's the ace. So I said that points can be one of two shapes of data. Either it's a hard value, and if it's a hard value, it's an integer, or it's a soft value, and if it's a soft value, it's this tuple. It's one of two values. So that's all that really means. And so I write this little function called card to points. And what it does is it says that if you give me a card, I'm going to return you back the points. And then I do some pattern matching here. If you've been playing around with C#7, you've seen some of the pattern matching with like the switch statements. They kind of got that idea from F#. For those of you in .NET, like Link and all that cool stuff, it always comes from F#. We're kind of the step brother no one wants to talk about. Anyway, but if we take a look here, though, so I match on the rank. If the rank of the card's an ace, I return that soft 1, 11. If it's a 2, it's a 2, 3, it's a hard 3. And then here at the very bottom, if it's a 10, jack, queen, or king, it's a heart of 10. Awesome. What I really like about this is this kind of reads almost literally like the rules would. I could give this to a business person. That I give this to casinos like, hey, here's how I'm doing the scoring. And they go, yeah, that totally makes sense. Because there's a difference between a soft 17 and a hard 17. I'm even using their domain terminology now. That's pretty dope. That's kind of cool. Okay, so I figured out how to do points. The hard thing now is I gotta figure out how to add these things together because they're not integers now. No, they're points. Addition doesn't work on points. I have to do something a little bit special. Let me show you. So I defined a new function called add points that takes in an A and a B of points and will return new points. So I pattern match and I go, okay, well, if I've got two cards that are hard, I'm going to return you back a hard of just the integers added together. So that first scenario would be like if I was handed a 10 and a 7. That's how that would work. The second scenario and third scenario are essentially the same. It's just that since addition for cards are commutative, it doesn't matter if you add A, it doesn't matter if you do A plus B or B plus A, it's the same value. I essentially say like, well, if I've given an ace and a 7, I'm going to add essentially the 1 to the 7 and 11 to the 7, so I'll get a soft 8, 18. Same thing for the third case. And for the fourth case, it's where you've got an ace and an ace. So if you do the math, you realize that you end up with like 1, 12, 12, and 22. 22 is invalid, so you get to chuck that one away. So that's why I defined it this way. The point's not to get so hairy in the details. The point is to realize that cool thing about F# is it forced me to have to handle all these situations. If I forgot one of these conditions, the code would, at worst case, it would warn me. If you turn on the compiler setting, it'll actually fail to compile. Say like, hey, you didn't handle all the possible use cases. That's kind of cool. Okay. So we've now, at a high level, we figured out how to get to how many points is a card worth, and we figured out how to add 2 points together. So how do we get points for our hand? I created another function called calculate score that takes in a hand, which is a list of cards, and I'm going to map them. I'm going to map that list into points, and then I'm going to reduce that list down to a single value by using reduce. For those of you who are Link or C# oriented, the Link version's below. Imagine hand was just a list. I did a .select. Here's the function to use to convert it, and then I did an aggregate. The weird thing is with an aggregate, you have to specify like a default value. So hard to 0, that's why it's there. But otherwise, those two are pretty much equivalent. That's pretty cool. I was able to model a problem, how do I figure out the points in my hand, using the instructions that somebody in the audience gave me. And I did it in such a way that the compiler could help me if I forgot to handle something. I like that. The compiler's helping me. I like that. It's not just bitching at me anymore. So, at the end of, the code for Blackjack's live. That's actually on my GitHub. You can totally pull that down, play it, and it supports up to so many number of players. And it doesn't have super advanced features, but it's enough to get the point across. So what I got really good at with Blackjack was actually handling errors without exceptions. And I'll show you a little bit more about that later on in the presentation. I got really good at pattern matching. Being able to define those types and then using that match with construct to make sure I handled everything, I got really good at that, which is super cool. I got really good at using built-in operators, map and reduce. Right? You saw me do that. How many times in Link do you do a select to convert something over, and then usually a where or something like that. I got really good at stuff like that. So now here comes the problem that you're going to run into, and I apologize at the beginning. You're going to really fall in love with functional, and then you're going to want to try to bring it into C#. Or you're going to bring it into wherever your day job is, and it's going to hurt. It's going to hurt really bad, because certain languages aren't there to support it, but I'm going to show you how it still affected me even in my C# code today, and really affected the way I solve problems. So, yeah, it's gonna be fun. It changed things. First and foremost, though, I'm a huge fan of unit testing. How about everyone else in the room? Because we all write unit tests for our day job, right? Oh, no, no, no. Remember, if you're looking for a job, he's in the room. You have to say, yes, I write unit tests, love writing them. I'll do it in my spare time, you know. So Roy Osherov wrote the book Art of Unit Testing, which is a fantastic read, especially if you're new to unit testing. You'll learn a lot of tips and tricks in there. But one thing he mentions in there, and it's kind of implied in the community, is that if code is easy to test, it usually implies that's easy to maintain. Okay, so does the opposite hold? If it's really hard to test, is it unmaintainable? Through my experience, yes. I've worked at a lot of small shops, big shops, startups, fortune companies, yes. So let me pose a question to the audience. Let's say that you're trying to unit test, or probably more realistically, trying to debug something. And you found the problem. It's this method. This method's doing something wonky. And so you're going through the debugger, and this method takes in 2 inputs. Which would you rather have to troubleshoot? That it returns different outputs for the same input, or it returns the same output? Which would you rather debug? Oh, you don't like it, interesting behavior? You don't like it not being consistent? No way. Developers not liking something inconsistent. Excellent. There is a piece of terminology for that. Methods that always return output solely based on their input, in the community will hear that term as pure or purity. Pure functions are awesome to work with because they're unit test. They're unit testable. You don't have to really stub out anything. They're super easy to work with. And I'll show you an example of that. There are whole languages and frameworks that everything is pure. There is no, they figured out a way to do pure network communications, pure error handling, things like that. And if you think I'm talking crazy or anything else, let me show you some of them. So everyone's probably heard of React and Redux. If you've ever used the reducers part of Redux, that's purity. Those are pure functions. If you use React with Redux, you can thank Elm, because Elm came up with that with their Elm architecture. Here comes the cool thing about Elm, though. Elm is a totally pure language. It won't throw exceptions, it won't do any of those bad things to you. Here comes the cool part. Because everything is pure, it has this feature called the time-traveling debugger. Now, this is dope. How many times has your QA been testing your code, and it breaks, but they have no clue what they did to cause the break? So they tell you it broke, but I don't have a stack trace, I have nothing for you because I have no clue what it did. Elm can keep track of all the commands it was sent and can export it. You as a developer can now import it and step through it. And you can see literally every interaction your QA person did to cause that bug to happen. But it can only do that because the stuff's pure. It can only do that. So this may sound like I'm talking crazy, but no, people are doing this stuff. Right? So let me show you an example of what pure code may look like in a more conventional sense instead of me just grandstanding a little bit about it. Ye old fizzbuzz. Oh, come on. It's not that. It's the only problem I found that almost everyone knows. So there's a couple of groans. The idea about, and so I'm not going to go spend too much time into it, but fizzbuzz is especially this implementation. It's an example of purity because if I pass in the number 15, for example, I'm always going to get fizzbuzz, not, well, sometimes it's fizz, sometimes it's buzz, sometimes it throws an exception, sometimes it... No, it's consistent. If I give you 15, it's always going to return fizzbuzz. That's pretty cool. Here's some examples of not pure. So let's say I'm running a point-of-sale system or some type of ordering system, and I got to figure out the total for an order. Okay, well, for me, total is going to be whatever the subtotal is plus the shipping. Basic, but just hear me out. But because I partner with another company to figure out the shipping costs, maybe I've got tight integration with UPS, FedEx, whatever, I've got like this little shipping service. I say, hey, given this address, I need to figure out how much shipping is. That's not pure. The minute I have to call it over the network, it's not, because the API may be down. It may not be consistent. It may not always do exactly what it's supposed to. So because of that, that's why it's not pure. The other example of impure is usually reaching out to file systems, databases, servers, stuff like that. That's usually where you run into problems. And now you're thinking like, well, how in the world does anyone get anything done? Different talk for a different day, but I assure you we do. So how are we doing so far? Is this kind of making sense? I haven't went off the deep end yet. Excellent. I got really good at Link. Oh snap. I went from noob to expert really quick. So let me show you. So here's the way I would used to do, now this is a contrived example, I grant you, but here's how I used to do my C# code. Really quick, what is this doing? From the audience, what is this doing? Okay, pause. Okay, so we kind of sat for about 30 seconds or so as people were chewing it. Let me help a little bit. Those are the things that really matter. I'm trying to figure out all the, so I've got a list of numbers. I'm trying to find all the even and positive numbers, and the ones that are even and positive, I'm going to convert them to a string and add them to a list. Contrived, yes, but realize how we all sat here and kind of stared at it for a little bit. But once I highlight that, it becomes blazingly obvious what I'm trying, blazingly, you know, air quotes there. It becomes more obvious what I'm trying to do. And the reason being is that I've got all this noise I got to sift through. What's this results thing running around? Am I doing anything crazy in this for each loop? It can be a little bit interesting there. So how would I have solved this problem in F#? Okay. So in F#, I would have written a couple of funcs, or a couple of functions there. So I would write isEven, which takes an integer and returns back a bool. Fun thing about F# is the single assignment operator, depending on the context, it will either be used for equality or it'll be used for assignment. Since F# you can only ever set a value once, that's why. But isEven is a function that says if you give me an integer, I return back a bool. So if x mod 2 is equal to 0. IsPositive says that, okay, well, if you give me an integer, I'll tell you if it's positive or not. And then toString is this kind of generic thing, which is kind of cool, that says if you give me an object, I'll return you its string version. So far, nothing too terribly crazy. And then to kind of do what I was doing on the last slide, I do numbers, filter. If you think where, for your link experts, you've got that. And then I'm going to map or select it to its string value. Okay? So that's kind of what I've got rocking around F#. So how would I translate that to C#? Roughly. So I'm just doing some inline funcs here. But as you can see, it's relatively the same code. But look at the very bottom there, that numbers line. So it's a lot more obvious in those last 3 lines what in the world I'm trying to do. I want numbers, I want where, it's even and positive, turn strings. I'm not having to sift through as much noise now. The other cool thing is, let's say that isEven, isPositive, and toString were more business rule-y. There are already functions. I could extract those out, do public functions in other classes, easily write unit test. It's easier for me to work with. Whereas in the old example, I would have had to have extracted out to methods first. All my business rules is tied into that for each loop. So here's the before and after. And even though I've added some more gratuitous white space in the example on the right, I actually end up with less lines of code. The other thing that's kind of cool is when I look at the right, I just see my business rules and it being glued together with link. I'm going to assume that link works. I have to make that assumption because if I can't assume that link works, that means I can't assume that the .NET framework works. And if I can't assume that, why in the world am I using this language? Okay, so the amount of scope of testability drops dramatically, which is kind of sweet. So my link got better. And something else that really got improved, designing interfaces that don't suck. Most developers that write interfaces are really terrible at it because they essentially do extract interface. Did it? No, you have not. You have done a very poor job. And we'll explain a little bit why in a minute. However, before Functional, I interfaced everything, all the things. Didn't matter if they would ever be substituted out, didn't matter anything. The only thing I would not interface were POCOs, and that was because my boss told me, why in the world are you doing that? Bad. He had to tell me not to. Otherwise, I may have done it. Okay? So I went from this to like all the things, maybe? So here's why I love interfaces. Interfaces are super powerful because they can enforce a contract at the code level. You can enforce that an object has a method called that thing with these inputs and returns this. If that object does not have that contract, the code won't compile. Heck yes, the compiler can help me here. It will not allow me to do a bad thing. This is one of the benefits of working in a statically typed language, right? The type system will help me here. JavaScript, unless you're using TypeScript, won't help you. Ruby will not help you. Python won't either, not unless you're doing like Iron Python or one of those variants, okay? So that means if I need to make a change to my contract, my compiler tells me, oh, these are all the affected places. Awesome, makes fixing super easy. That being said, pop quiz. Here's an interface. What does getById return? It returns an employee, right? Anything that implements this interface will always return an employee object, right? That's what the contract says. Don't do this. Okay? So that's one way that the contract lied to me a little bit. It said it always returned me an employee. Well, null's not an employee. That doesn't help me. Or, my personal favorite, I'm going to throw an exception. The ultimate escape hatch. No, I don't have to do anything you tell me. The ultimate table flip. Seriously, don't do either one of these. Okay, let me show you a more realistic example. So here is some C# code that's doing ADO to get employees where the ID is set to a very particular value. And I'm going to pull out the real key part for you. That's the key. It's very likely when I'm trying to retrieve an employee with this ID, the employee might not exist in the database. Maybe because we haven't hired them yet, maybe someone flipped a 1 and a 0 around, whatever. What do I do? What do I do if there's not an employee in my database? And this is just basic stuff. This is basic CRUD. I'm not talking about crazy business rules here. What are my options? I either do the null object pattern, which means I create an employee with some reasonable defaults, but now I have to special case on my business rules to make sure like, well, if this is empty, really what you want to do is show an error message. Or I throw an exception, in which case now all my code has to remember, oh yeah, by the way, that may throw an exception. I have to remember as a developer, put a try catch because the compiler sure as hell won't help me. Or it returns null, so now I sprinkle if null checks throughout my code base to protect myself from this, which also doesn't help because the compiler can't do that. Sorry, it really irritates me. So I'm going to kind of shoot through this. It really irritates me because I'm paying the tax of statically typed language and it's not helping. So how would I do this in a different language? So here's how F# handles it. Now this is some F# code. Don't get too scared. It's not that bad. I'm going to once again pull out the part that matters. It's that very last line. So matches is essentially a sequence or an IEnumerable of all the employees that were returned back from that query. Okay? I'm going to see if it's empty. If it's empty, I'm going to return this built-in type called an option. I'm going to return the none value for an option. Okay? Otherwise, I'm going to return back the first value of the sequence and I'm going to wrap it in SOM. And if you take a look at the signature for getEmployeeById, it's not an int to an employee, it's this int to employee option. Okay? This is where the power of functional programming starts helping us out. I have a type built into the language that says that there may be a value here, there may not be. Okay? So let me show you a little bit more of an example of using getEmployeeId in code. So let's say I have this function called printEmployee, and what it's going to do is it's going to, if you give it an ID, it's going to get the employee from the database and it's going to print to the screen. This code does not compile. And the reason why it doesn't is because when I get that employee by ID, when I get that value, it's an option. That option has no clue what an ID is, has no clue what a last name is, has no clue what a first name is. This code won't compile because the compiler is telling me, hey buddy, there may not be a value here. You have to handle this. All right, so how would I handle that in F#? More pattern matching, yay, match with. So when I get that employee back with ID, I'll do a pattern match. I'll go, hey, if I've got nothing, I want to print this to the screen. If I do have something, I'm going to call it EMP, and I'm going to print that to the screen instead. That totally works. Oh snap, the compiler just helped me. Okay, now you can try to make this work in C#. There are libraries out there to do it, but it gets a little bit more interesting. If you are interested in trying to model this, there is a NuGet package called Optionally that I wrote that handles this pretty well. And the docs actually don't suck. You're welcome. But if they do, please let me know. I will gladly fix them. So just these ideas. So kind of rehash a little bit about what I've learned. I learned how to write more pure stuff and why that matters from a testability perspective, and I'll show you that in a minute. I learned better link, got really good at that. And I also learned a lot about how to actually deal with these things. You were talking about, okay, cool, maybe we always throw an exception because there's not an employee in there. There are other real life use cases where an option would come up. I'll give you an example. Drawing cards from a deck. If a deck's a list, what happens when the deck runs out? What do you return back? It's not always a card. So there are plenty of valid reasons why you would want to use an option. That being said, so with all of that, I want to talk a little bit about how it actually changed the way I build software today, about how I think about component design, everything. And so with that in mind, there's really three big pieces. I think most of the software I work on, because I don't do data science, I don't do machine learning, I don't do any of that stuff. But in my day-to-day job, I feel like software is broken down into one of three components. The first component is boundary. And this is your data in, data out. This is literally getting your input from files or from the user, a web interface, whatever that case is, and sending that data out, whether it's through emails, putting it in databases, logging it, that type of stuff, okay? And as the name implies, it's on the boundary, it's on that edge. The second component is your business rules. This is literally why you're writing the application. This is that filtering, this is those calculations, this is that data transformation. It's that stuff, okay? And then I have this third component called workflow, which is the combination of these two things, okay? For those who may be thinking ahead a little bit, boundary components, you would always have to write an integration test on them because they're literally doing database stuff. They're literally doing file manipulation. They're literally doing that stuff. Business rules, they're always unit testable because they're pure. Your workflow, you could use mocking to write unit tests on, but most of the time, I just let them integrate test because they're already impure because I had to put the boundary in there. But we'll talk about that a little bit more in detail. So as I mentioned before, boundary, it's stuff like databases, files, APIs. They're typically impure. Always throw an interface around your boundaries because you want to be able to substitute them out, especially if you want to put a mock in. I swear if I catch you making your boundary a static class with static methods, I will beat you. I will come find you because it is the worst of everything. I can't unit test it, I can't mock it, I can't do anything. And this idea of boundaries and putting this up is actually a pretty well-known concept. I first learned it from hexagonal architecture by Alistair Coburn. You've also heard this in onion architecture or clean architecture from Robert Martin. Those come up. So this isn't like some super crazy new term I came up with. Once again, it's been around for a while, of course. So let me show you some examples of boundaries. So we saw the FizzBuzz class a little bit earlier. I'm going to write a small program that's going to prompt the user for a number, like what's the high range of what you want to go to. Instead of the typical 100, how high do you want to go? And then I will generate the FizzBuzz numbers for that list, and then we'll print them to the screen. And I'll show you how I would do that. So here's my first boundary, this number retriever. So my interface has a single method called getUpperBound, returns back an integer, and then I've got this console number retriever because I'm getting it from the console. I'm already thinking ahead. If I need to get from a file, there will be a file number retriever. If this is going to come from an API call, maybe it's an API number retriever. And it's doing nothing crazy here. It's console write line, and then I'm returning an int 32 parse. Your astute readers are thinking like this is going to throw exceptions. What if I put in all this other crap? I'm actually okay with that right now for the example. In reality, I would probably either put this in an option or its brother type called result. But just to kind of get the point across, this is kind of what I'm trying to do. okay? And so if that's how I'm getting data in, how am I sending data out? Well, I'm going to print that to the screen. And so I have an interface called printer. It's a void method. It takes string as an input, and then I've got a console printer. Something to note, you can usually identify a boundary based on the method signatures. This is a boundary because it's a void method, which means it can do anything, and it takes in some input. Void methods typically are impure. That's usually what they mean. They're either mutating the state coming in, and that's how they're doing something, or they're like sending data out into the world. Otherwise, why would you call this void method? Because it doesn't return anything. Another sign of a boundary is a method that takes in no inputs but then returns you values. Where did it get those values from? Had to get them from somewhere. So that's boundary. Let's talk about business rules. Bulk of the application are your business rules, right? At least should be. And the key thing here is to try to be as pure as possible. If it's going to be impure, shove it to the boundary. Otherwise, keep it here. And when you're writing this code, remember, solid principles totally apply. You still want small classes with those single line methods. You're still going to want to use interfaces when they make sense. You still want to pass in your dependencies when they make sense. It's not like those rules go out the window. And so an example of a pure class is the FizzBuzz calculator that we've already looked at. Okay. So workflows, remember we talked about this. It's a combination of boundary and business rules. And so the general shape I found with my workflows are data comes in through the boundary, business rules happen, data flows out the other boundary. And so the workflow is responsible for taking in the boundaries usually as injected through a constructor. And then the workflow will actually new up the business rules it needs inside because it's the workflow's job to know which business rules it needs because it's the workflow. It's literally the one dictating the work that needs to be done. So here's an example of the workflow class, and we'll break it down a little bit. So that first section is the constructor level arguments for the number retriever and a printer. Remember, those types are interfaces, so that's why I'm stashing them that way. So I'm just setting them there for now. Sorry, my naming for workflow is kind of bad, but that's okay. It is what it is a workflow. And for the method, it's just called do FizzBuzz in this case. First thing is, I'm going to pull some data in. So I'm going to do number retriever dot get upper bound, get that max. Okay. I'm going to do my business rules. I'm going to get an enumerable, so that's going to create the numbers 1 to whatever max is. And I'm going to new up that calculator, and I'm going to do, hey, results are going to be numbers, wherever that range is, dot select, hey, there's link coming back again. Once you turn each of those numbers into whatever calculate FizzBuzz would do, and then I want you to go ahead and to list that, because I want to automatically have that list. So at this point, I've got a list of strings, because they've already been turned into either their number or FizzBuzz or whatever. And then for the last part, I'm going to send that data out. So for every result, I'm going to call printer.print. Because I follow this, if I need to add additional business rules, it's pretty clear where I need to add them at. If I need to switch how I'm sending data out, it's pretty clear where I need to do that at. If I'm pulling data in from an additional source, it's pretty clear on where I need to do that. And what I really like about this is literally follows a workflow. So if someone says, hey, we're getting the wrong value for 5, it's giving us fizz and it's supposed to be buzz, I know immediately where to look. I don't care about how the data came in, I don't care how the data came out. I really care about like, hey, are we calculating the right thing? That's awesome. This makes troubleshooting and debuggability for me amazing. In closing, functional was tough for me. It was tough for me because there were a lot of times where I had to learn a lot of new terminology and it was scary, and that was okay because we all came into this not knowing what a factory was. We all came in not knowing what statics were or the abstract helper factory bean, if I can poke fun at Java developers for a minute. But we learned it on the job because we kept using and finding examples. Functional's the same way. I just said option, you all were like, what in the hell's that? But you saw an example and you go, okay, that's not so scary. Same thing with functional. You're going to find a lot of terms that are going to sound foreign to you, and that's okay. As you start using them, as you start applying them, they'll start making sense. My big thing is don't give up on that. If you have questions about like functional concepts, feel free to hit me up on Twitter. My biggest advice though is if you're really wanting to learn functional, pick a functional language. And even though I really appreciated F#'s like .NET interoperability, in hindsight, I wish I hadn't used it because it allowed me to fall into some of the traps of writing OO at the beginning. If you're a JavaScript person, Elm is a great place to start. PureScript is another great option. If you want to be like, you know what, I want to try some crazy language that's not even related to my day job, Haskell is pretty good, especially if you pick up the Haskell book by Julie Moronuki and Chris Martin. It's expensive, it's like $60. However, it goes from you don't know anything to like, I know Kung Fu. And it's very, like, it's really good and deep. I mean, it's like a 2,000 page book. That's why it's ebook only. It's very, but it's a super fun read. Tons of chapter exercises, great conversations, and there's a lot of people out there going through the book, so more likely than not, you might know somebody who's going through it. So that's it for this, the talk itself. Everything I pretty much referenced except for the Julie Moronuki book is shown on the references slide. If you do want to do F#, F# for Fun and Profit is a godsend. It's better than the Microsoft Docs. I kid you not, it's absolutely amazing. It's by a gentleman named Scott Vlashin. Does a lot of cool talks about error handling, all sorts of stuff. It's just a great resource. If you're more of a book person, the book of F#, Breaking Free with Managed Functional Programming by Dave Fancher, slightly dated, but a lot of the concepts still hold. And if you're plural sci, F# Jumpstart. If you want to learn more about functional in general, Mark Siemens' blog, blog.ploy.dk, is amazing. Just read it. Take the whole thing, download it in your head, and you'll know Kung Fu as well. Hexagonal Architecture, I've put a link to that. And Reed Evans, he also co-organizes the functional stuff in Knoxville with me. He actually has a YouTube channel where he did for 2 months, he would do something functional in JavaScript or PureScript or whatever. And be like, oh, hey, here's like a quick 10-minute video on how I used options and like how to work around that stuff, which is pretty cool. If you're wanting to be like, all right, Cameron, your code examples are okay, but these are all toy crap. I want to see something a little bit more heft. Check out Cruddy. It's actually a C# console app that does CRUD operations written in a functional manner. So, and it will not throw an exception on you. And the way I do that is I actually use Optionally, which is a library that handles the options and results, so error handling. So pretty cool stuff there. Did everyone get a picture of the references that needed a picture of the references? Excellent. So feedback. If you have the cards, please leave them in the blue bag in the back. Otherwise, scan the QR code. It'll dump you to a Google Docs. And it's a single question thing that you can say yay, nay, or boo. And then give me more feedback if you need to there. But I really would appreciate it because I can't get better without you all helping me. So, and the slides, if you also go to my website, go under presentations, pretty much all this content's there already. The only thing is the slides not been updated yet, but they'll be updated right after this talk. Otherwise, that's pretty much it. Thanks all for joining me this morning. All Brian Bushy Tail, I really appreciate it.